My name is Steffen Kux. I'm the Director of Software Development at Blockchains LLC. Last year in Sydney, I already had the opportunity to speak at EDCON and presented the working status of the Incubed protocol and the Incubed client. Today, I want to focus on the importance of stateless but fully verifying clients for the Ethereum ecosystem and present the productive Incubed protocol and existing tools and APIs which enable developers of web, mobile or IoT applications to interact with blockchain in a secure, decentralized but resource-saving way. For those of you who may know me or slock.it, most likely you have heard that slock.it was acquired by Blockchains LLC last year. Now that the integration of the two companies is complete, slock.it is working as the development lab for the company, now under the Blockchains name. Our vision and mission, and some of you may remember the presentation of Jeffrey Burns, our CEO at Park in 2018, is to reimagine and to build the infrastructure and tools needed to empower individuals to manage their digital assets and identity. A decentralized and secure way to interact with blockchain without intermediaries who must be trusted or who could be the single point of failure is an essential part of our solution. With Incubed, we provide a stateless client which can verify all information from blockchain by itself with a crypto economic security, but without the need to synchronize all data. This client is with about 300 kilobytes and very low connectivity needs, the smallest Ethereum client available. It can be used effectively in web or mobile applications, but especially it is also meant to be used in IoT devices, which usually have very strict limitations in terms of storage, computing capacity, and transmission bandwidth. When Ethereum was conceived, the vision was to have a distributed peer-to-peer network of independent nodes with synchronized state of the blockchain, and having access to the apps using these nodes completely without any centralized services. In fact, the need to access this information from any kind of application, like web pages, smartphone apps, or IoT devices, in the past it seemed to be necessary to use centralized remote servers, because in most cases it is hard to or even not possible to run a synchronizing node or even a light client in this application or device. But it's a kind of paradoxon. We connect to a decentralized world using centralized service. Another problem is that such a remote client needs to trust this service because it's not able to validate and verify the received information. However, centralized remote services are and must be a bridge technology only, and now it's time to go the next steps. The solution is to use stateless verifying clients. Such clients do not synchronize block information, but use proofs and validation signatures to verify and validate all information autonomously. Blockchains LLC introduced and released such a protocol stable on mainnet as Incubed in January 2020. Usage of such clients combines the security of a light client with the advantages of a remote client, at least for the most common IoT solutions and mobile and web applications. With Incubed, it is possible to connect devices and applications completely decentralized without any centralized instance and with crypto economical security. Any active full node can potentially participate by registering in the Incubed registry and logging a security deposit. In addition to the blockchain node like Geth, Ethereum, Nethermind or others, the EM3 API layer is needed, which passes the Incubed request to the node and returns the results, proofs and validations to the requesting Incubed client. The Incubed clients can access this list of potential nodes to communicate with them. Out of this list, they select the nodes they need to communicate. If an information is needed, the Incubed client selects one of the nodes and sends an RPC request similar to a remote client to that node. This node is selected randomly with some additional rules. The same node is never used for subsequent queries. The Incubed client now receives the response from the node. In addition, it receives the block header and the necessary Merkle proofs to be able to verify independently that the received information belongs to this block. At this point, the client knows that information belongs to the block but cannot independently check whether this is actually a correct block of the blockchain or not. To do this, the Incubed client selects additional nodes from which it would like to have a validation. The only information we can check on-chain in the past, and we need to do this on-chain to convict misbehavior in the registry contract directly, is the block hash. Therefore, the client asks one node for the information and requires the validators to sign the block hash of the corresponding block. With this information, the Incubed client can now independently validate that this is a correct block of the blockchain and the received information is part of this block. If a node signs a wrong block hash or delivers wrong information, it will be convicted in the registry, will lose its deposit, and will be thrown out of the network. With this, we have a crypto economic security that the transfer of incorrect information for the node means the loss of its deposit. On the other side, the client can decide which and how many nodes it asks for validation. Every signed information is checked always, and if misbehavior is detected, the convict process is started automatically. Additionally, it is possible to run watchdog nodes to actively scan the network for misbehaving nodes. The second part of the crypto economic model is an incentive system for nodes to receive a micropayment or better a nano-payment for signed information. With this, the client pays per request or bundle of requests for verifiable and validatable information. As we are on a developer conference, let's have a look into some code snippets in various languages to see the easiness of using Incubed in the daily programming work. Our initial focus was on the use in small IoT devices based on microcontrollers. To be integrated into their firmware, embedded C is the only real option. Therefore, the complete client code, including the EVM, is implemented in C. The Incubed core libraries, which are available as open source, contain interfaces for connectivity and data transmission, verifiers for Ethereum, IPFS, and Bitcoin, which is not yet released, APIs to access RPC functions in the firmware way, and bindings to different common programming languages to make Incubed available for any kind of applications. Today I will focus on these bindings by going over some code snippets to show how to integrate it into software projects. As mentioned before, the footprint of Incubed is very small, starting with about 300 kilobytes and no additional external dependencies. As said, everything is based on our C code, which is interfaced into languages like Python, Rust, C#, and Java, or translated into Vasen to be available in JavaScript too. By the way, as said on the previous page, there are 0 dependencies also for the JavaScript Vasen version, which makes it easy and secure to be integrated in web pages or mobile applications. As JavaScript is commonly used in the crypto community, I will start with this. After installing the npm package en3-vasen, the client can be instantiated and use current API functions. All the protocol features like which nodes to select, checking the proofs and validations, blacklisting nodes with bad performance, convicting misbehaving nodes, and so on, doesn't require developer interaction, although it can be tuned and configured manually if needed. Users of the Web3.js library can switch to Incubed by simply changing the HTTP provider using the Incubed client instead of the local client, or connection to a remote node. This is shown in the second box. IoT devices or C and C++ applications can use the C libraries directly. After instantiating the Incubed client and defining the data transport protocol, an example curl is configured, the APIs can be used. The memory usage, of course, depends on the functions which are executed. For instance, a complex smart contract call may take much more resources than simply check of account balance. Nevertheless, a fully verified client runs with less than 128 kilobytes RAM usage. For Python, the pip package IM3 is also available. The Python client also gives access to the full API. The usage is as simple as in C or JavaScript. Also, Rust developers can integrate blockchain connectivity with Incubed directly by using the Rust binding, which interfaces the C library into Rust, as well as Java developers and C#.NET developers. Other platforms and languages will be added soon. I would like to emphasize one more thing. Besides the binding of the different programming languages, there's also the EN3 command line tool available, which allows you to interact with Ethereum directly from the console, integrate blockchain interactions into scripts, and so on. Additional helper functions like signing with private keys, including interaction with hardware wallets, are also available. Remember, no synchronization is needed, just running the command. As summary, let's have a look at a roadmap and how to access Incubed resources. During the last 2 years, we developed the Incubed protocol, the client and the node software. After the security audit end of last year, the stable version of the Ethereum mainnet was launched in January this year. Since then, we focused on making Incubed available for as many as possible platforms, including the presented Python, Java, Rust, and .NET bindings. Those were and are published in incremental releases. The verification of Bitcoin transactions on Ethereum is almost finished, and the incentive layer is in work also, and is planned to be released in Q4 of this year. After this, the integration of ETH2 and other blockchains and verifiable protocols are scheduled for 2021. Last but not least, here's a list of some important resources. The full Incubed documentation, including APIs, examples, and so on, you can find at Read the Docs. Source codes for the node, the client, and the bindings to the presented platforms you can find at GitHub. The code is available as open source or dual licensed with a commercial license if needed. Also, we invite everyone to register his or her node to the Incubed network. To make it easy, a wizard at in3-setup.blockchains.com is available. Please don't hesitate to contact us via Twitter, email, or other media if you have questions or need support. Thank you very much for listening and watching.
Hi, my name is JK. I am part of the team at stakefish. Stakefish is an infrastructure provider for blockchain projects. For the past 2 years, we've been running validators on different proof-of-stake networks, and we've also been running nodes for projects like Chainlink. We're very excited to support the upcoming launch of Ethereum 2.0. And today I wanted to address ETH holders who might not be as knowledgeable or have not been following closely what has happening with Ethereum 2.0. It's not too late right now. Now's a great time. We still have a few months until the actual launch happens. And now's a great time to start thinking about why you should be staking ETH, what the risks involved are, and then also what sort of homework you should be doing right now. So Ethereum 2.0 has a lot of major upgrades included in it. That's why it's being rolled out in phases. Phase 0 will have the introduction of proof of stake. Phase 1 will have then sharding, and then phase 2 will finally have smart contracts enabled on Ethereum 2.0. And that's when Ethereum 2.0 will finally look a lot like the proof of work Ethereum today. Now, when people talk about the launch of Ethereum 2.0 that's upcoming this year, what they're referring to is the launch of phase 0. Phase 0 will see the Beacon chain launch. The Beacon chain will use proof of stake for its security rather than proof of work. Now, proof of work, you need a lot of GPUs housed in data centers with very low electricity to even participate in mining and providing security to the Ethereum network. With proof of stake, with only 32 ETH and a PC at home or laptop, you'll be able to participate as a validator and provide security to the Ethereum network. Arguably, this is much more decentralized and then lowers the barrier to entry for everyone to participate in the act of providing security to the network. As I mentioned, phase 0 is almost here. Currently, we have already attack nets live. Attack nets are where developers are incentivized to try to bring down some of the Ethereum 2.0 software. We also have the public Medasha testnet live. The public Medasha testnet is where anyone will be able to participate as a validator with testnet ETH. And currently we are at this stage. And once the Medasha testnet has been running without huge incidents for the next 2-3 months, we will finally start deploying the deposit contract. The deposit contract is what will act as a bridge to the beacon chain. Ethereum ETH holders on the current proof of work Ethereum chain will be sending their ETH to the deposit contract to then be issued ETH on the beacon chain. But keep in mind that this is a one-way bridge. Once you start sending ETH to the deposit contract, you will not be able to get your ETH back on the proof of work Ethereum chain. And finally, once we have enough ETH deployed on the beacon chain and enough validators participating on the beacon chain, phase 0 will officially launch. The official date has not yet been set for phase 0, but I wanted to point out that there is a prediction market live, and people are still heavily betting that phase 0 will launch in 2020. Now let's briefly talk about why you should consider staking. And the obvious first answer is that you will be able to contribute to the network security. As an ETH holder, you want the network to be secure and more developers to start building on top of it. And so it is your duty to make sure that the network is secure by staking some ETH. Arguably, you'll also be promoting decentralization because now people from anywhere around the world will be able to stake. And so if you're living in an area that might not be heavily represented in the proof of work space, you will now be able to represent that region by staking. And I know obviously this is what people are most looking forward to. You will start to receive staking rewards. And proof of work miners received a new ETH for providing hash power to the network. And proof of stake, similarly, validators will now start earning staking rewards. And now, as a benchmark, the Medasha testnet has around 860 ETH staked. Those 860 ETH are currently earning around 16.8% in annual staking rewards. Now, however, the rewards here are not risk-free. There's obviously a lot of risks involved with staking. The first of which is that Ethereum 2.0 will be very early stage software. While the teams have spent ages doing a lot of research and developing the Ethereum 2.0 software, and most of these have gone through multiple code audits, it's possible that there are still unforeseen bugs, and these bugs could cause some problems. Also, in proof of stake, if a validator tries to do anything malicious, or if a validator is offline for too long, they'll see their balances decrease. We call this slashing and penalties. And so you got to consider the risk that your validator could see your balance decrease in the event that slashing or penalties happen. But the biggest risk I wanted to highlight here was that in phase 0, you will not be able to withdraw your ETH. I wanted to repeat that again. So at least until phase 1, which is planned for 2021, any ETH that you start staking in phase 0 will need to wait until phase 1 before you're able to withdraw it. And so while 2021 is the expected launch year of phase 1, because there is no date set, technically you'd be locking up your ETH for an undefined amount of time. And so you've got to take that into consideration when you start staking. So now that you're aware of why you should be staking and what the risks are, so let's go through some of the things that due diligence that you should be starting today. And I've tried to boil this down to four steps. Step one is trying to determine how much ETH you should be staking. I've already outlined some of the risks, especially around how ETH will be locked until at least phase one. This definitely means that you should not be staking your life savings into on the Beacon chain at all. And even if you have some emergency funds set aside and just a sizable ETH holdings that you want to stake, you should really consider diversifying your hedging your risk by keeping a set ratio of your ETH still on the proof of work Ethereum chain. And thankfully, thanks to a lot of the DeFi products out there, even if you're not earning the staking rewards from the Beacon chain, there will be plenty of opportunities on the proof of work Ethereum chain for you to earn some yields on your ETH holdings. So definitely do consider setting aside some ratio of your ETH on the proof of work Ethereum chain, and then some amount on the Beacon chain to stake. And then the next step is to try to run your own validator. I want to emphasize that Ethereum 2.0 has been designed such that anyone from home should be able to run a validator. And I totally understand that running a validator might not be for everyone. Some people might just not have the time, and some people might not be technically capable enough. But you wouldn't know unless you try. And that's why the Medasha testnet is a perfect place for you to try to attempt this. The Medasha testnet replicates how the phase zero change, the Beacon chain should look. But all the ETH that you would need for running a validator on the Medasha testnet will be testnet ETH. So you're not technically putting any of your own money at risk here. So definitely, and the Ethereum Foundation team has put together a very great website at medasha.launchpad.ethereum.org, where they take you through the steps of how the steps you need to take to run your own validator, and they're very intuitive. So I highly recommend going through these steps to determine whether or not you will be able to run your own validator once phase zero comes along. Now, if you've determined that you might be able to handle running your own validator in step two, you don't really need to go through step three. But for those people that still feel uncomfortable after going through step two and want to try to delegate this task out to someone else, you'll need to go through this the step three process, and which is where you start assessing and trying to narrow down some candidates for where you could some third-party validator candidates. And I started to bucket these into three large categories so that it's to give you a starting point on how to approach and think about third-party validators. The first are the exchanges and custodians, and they'll definitely be offering the easiest form of staking. They'll likely take custody of your ETH and then provide and then stake for you. But obviously, the risk here is not your keys, not your coins. If the exchange or custodian does make some mistake in how they handle the keys, your funds could technically be lost. The second category are staking pools. This is where if you don't have enough ETH, for example, if you don't have 32 ETH, you'll be able to pool your ETH with other community members to co-own or co-run validators. The risk with staking pools, however, is that pooling will likely happen through a lot of smart contracts. And these smart contracts, while they might be audited sufficiently, there still might be some loopholes in there. And you'll need to definitely think about how to hedge your smart contract risk. The final category are the validator as a service companies, projects like us. We will not keep custody of your funds. You will fully have custody of all your ETH, and all we will be doing is operating the validator for you. The biggest problem with using a validator as a service is that you will need to have the full 32 ETH amount. So for example, if you have 10 ETH or 5 ETH, you might not be able to use the validator as a service and will need to consider the staking pool route, or perhaps the exchange staking route if exchanges support staking for less than 32 ETH. Now, now that I've outlined some of the categories of third-party validators available out there, these are some good questions that you could start asking, creating a checklist to see which projects, companies fall in, meet your standards or your requirements for a good third-party validator. I won't go through these specifically, but I've just laid these questions out. There are definitely a lot more questions to ask on top of these. I highly recommend talking with the team directly, interview them. Most of the third-party validators should be open to answering these questions and more. And finally, once you're through all those steps, next up is to follow the latest updates around Ethereum 2.0. The reason why I say this is because the exact date of the launch is still unclear and could be announced anytime soon. And so it's very important to pay close attention to the official announcements. I want to emphasize paying close attention because I expect a lot of scams to start appearing as we approach this milestone. And I wanted to present some solid ways that you could follow for the latest news around Ethereum 2.0. The obvious strongest official website to go for the official news around Ethereum 2.0 is the Ethereum Foundation blog. But the other two good resources to also use is Week in Ethereum. Week in Ethereum should be familiar for a lot of the Ethereum folks out there. But also to add on your list is What's New in ETH2, which is heavily focused around the latest updates around Ethereum 2.0, and also includes a lot of good notes around the developer calls or developer meetings who are developer meetings around Ethereum 2.0. Now, I definitely did not have a whole ton of time to go into detail around each of these steps or even through why you should be staking and risks around staking. Definitely, there's a lot of good reading material out there. We ourselves also published a good basic article around Ethereum 2.0. Definitely recommend checking it out on our Medium channel. Well, we also have now a landing page live on stakefish website. You'll be able to find a calculator there and then find FAQs around Ethereum 2.0. And most importantly, don't hesitate to reach out. You can find my email down there and also my Twitter handle. We're here to help you out. We're happy to answer any questions. And yeah, let's